Hi everyone, I want to welcome you to this section even though it has been a long time. I also want to apologize for late response to requests to speak more further on this particular topic where I explain terms related to calculating the maximum wavelength of absorption involving Woodward Fiesher's rule. So in this video I will be talking much. I will just revise what I've said about these terms, then try to show us how to go about calculating the maximum wavelength of absorption. So from the previous video I've explained some of the terms that are used in computing the maximum wavelength in Woodward Fiesher's rule. One of them is talking about homoannular dying, where you have two double bonds within the same ring. That's homoannular dying. And you also have heteroannular dying. You can also have this situation where you have the two double bonds inside different rings. Now this homoannular dying can also occur when one of the two conjugated double bonds when one of them is within the ring and the other is and the second double bond is in a linear system. So it's not compulsory that the two double bonds should be within different rings for heteroannular. Even if as much as one, it is only one of the two conjugated double bonds that is with separate ring, that the two double bonds are not within the same ring, it means it should be heteroannular dying. Now you can also have a conjugated double bond, like I said in the previous video, in a linear system where no ring is involved, but that's an acyclic situation. And so we have basically three forms of dying system that you can see. You can see an homoannular where two double bonds are within the same ring. You can see a situation whereby two double bonds are in different rings, and you can also have a conjugated system in a linear compound where you have an acyclic dying. Now remember now considering this structure here, you will see that one of the double bond is within the ring while the second double bond is outside the ring. So this is also an heteroannular dying situation. Also, if you look at the next structure beside it, the same thing. One of the double bond is within a ring while the other is outside the ring. So it's still an heteroannular situation. Now the last structure here also is it's also an heteroannular situation where the two conjugated double bonds are in different rings. So but these three structures here are trying to show us that double bonds can sometimes have isocyclic structure, and I've talked about that also in the previous video, that when you have a double bond that is directly attached to a ring system, then you have an isocyclic double bond. Now this is also a situation where you have when you can also want to consider a key substituent, or you might want to consider ring residue. And I mentioned in the previous video that these terms, you can use them interchangeably, but in a much better sense they are two different things, because this is, yes, the two of them talks about an sp3 carbon. So anything that will be a ring residue or an alkyl substituent must be talking about an sp3 carbon that is directly attached to the conjugation system. I've mentioned that also in the previous video, but you can use them most times people use them interchangeably, but make sure that the sp3 carbon you are considering either as a ring residue or a key substituent is directly attached to the conjugation system. So if you look at this structure, there are four there are like four alkyl substituents here, and here also you have three alkyl substituents. I'm using those two words interchangeably now, so just permit that. And this is a situation where you have double bond extending conjugation. So all of these I've talked about them in the previous video, so if you are just joining us, you can just watch the video before this so that you can have a better you can understand all of these terms before starting to do the computation aspect. So now to compute lambda max, the maximum absorption wavelength value, you need to understand some of these basic values, some of these basic lambda values for different components of any structure given to you. So when you are given any structure, the first thing to look for is what kind of dienes do I have. So if it is heterocyclic, if the structure given to you has an heterocyclic conjugated double bonds, then, or if it has if it has an acyclic diene, then it means the lambda value, the basic lambda value, will be 214. These values are not let me say, they are not fixed, so in some cases you might see some other like values in some other textbooks, but but this is just like, it will still be within this particular range. So we have 214. Now if the conjugated double bond is in this is in homoannular situation, then the basic lambda value will be 253. So I'm going to talk about an example on this. Now there are other things you have to consider after determining the basic lambda value to assign to any structure given to you, whether it is heterocyclic or acyclic, which we get at 214, or whether it is basic homoannular diene, which we get a lambda value of 253. So you also have to consider some of these additions. We call them oxochromes because this set of additions, they only enhance absorption of the compound. They particularly they don't absorb the UV light. They don't absorb, but they enhance absorption. So in most cases, most of these additions tends to increase the basic lambda value, and that's why you see +5, +5, +30. So when you have all of these other components in any structure given to you, then you add these values to your basic lambda value. So the first thing is to determine the basic lambda value, which can either be 214 or 253, depending on the kind of dienes that you have there. Now the same thing, so you have to check for all of these additions. You have to check for ring residues, you have to check for double bond that is isocyclic, you have to check for double bond that extends the conjugation. And I mentioned in the previous video that for you to have double bond extending conjugation, it means that you are having more than 2 double bonds. So for each double bond extending conjugation, you add 30 to this basic value. I'm going to show an example on that. So there are other substituents that could also be attached to the conjugation system, the 2 double bonds, the dienes, the 2 double bonds that are conjugated. There are other things that could be attached to them, which include all of these. Sometimes you can have chlorine directly attached to the conjugation system. You can have thiol ether, you can have alkoxy, you can also have something, this group, this OC, this acetyl group. Yes, you can have this group also attached to the conjugation system. So all of them has an impact on the basic lambda value, and you have to consider them. So let's look at an example for conjugated dienes. This is the first example that we are going to look at. So we have this ring, this structure was given to us, and we want to determine the lambda max. So if you look at this now, the first thing to consider is to identify the basic conjugated system that you have here. And the basic conjugation system that you have here is these two double bonds that are separated by a single double bond, so they are conjugated. Now this third double bond is not part, because there are two single bonds between these two double bonds. So it means that this double bond and this double bond are not conjugated. So the only thing you are considering is this system. So this is your conjugated two double bonds, and because they are in different rings, it means it is heterocyclic. And for this system, you assign, like I said, the basic lambda value will be 214. So that's why you have it in this place. So you now begin to look for other additions that I've mentioned: isocyclic, ring residue, double bond extending conjugation, and all of that. So in this case now, there is no double bond extending conjugations, because this is not part of a conjugation system. So it implies that there is no double bond extending conjugation. Now here we have this double bond is isocyclic. If you remember how I've described isocyclic, it is a double bond directly attached to a ring system, and at the same time it's outside our ring system. So this double bond is isocyclic to this ring because it is outside this ring and it is directly attached to the ring at this point. So we have one isocyclic double bond and there are three ring residues, which is 1, 2 and 3. If you look at all of these carbon I've identified 1, 2 and 3, they are directly attached to the conjugation system, and that's why we have 3 ring residues. So for each ring residue you had 5, so that's why we have 15 here. For each isocyclic double bond you had 5. So now if you look at this structure, there is no other additions in this place, so it implies that so we just sum up all the values that we have: 214 plus 5 plus 15, and then we have 233. If you look at the second example, the two double bonds here, we also have a conjugation system here, which is this. So please always check if the double bonds are if the two double bonds are truly conjugated. It's very important. If they are not conjugated, there is no need computing the lambda max. You must have a conjugated double bond before computing the lambda max. So these two double bonds here are conjugated, separated by a single bond, so and they are within the same ring. So the parent value of the parent lambda max would be 253, and also you check for ring residue, isocyclic, double bond extending conjugation. There is no isocyclic double bond here. At the same time, there is no double bond extending conjugation, so it means that you only have to look for ring residue, and there are 3 ring residue, which includes 1, 2 and 3. Those are the 3 ring residue, and you have plus 14, so plus 15. And there is also an alkoxy here, which is also directly attached to the conjugation system. For that you had 6, and that's why you had all. Then you since there is no other additions in this case, so you had them together, and then you get to 74. Now this is how you always go in calculating your lambda max. So in the next video I would also discuss I would do more examples for you on these, and also discuss the next set of conjugation system, which is alpha beta unsaturated carbonyl system. Thank you.